So, who has two thumbs and has been trawling Facebook Marketplace? This guy. Yep, I apparently just can't help myself. This machine popped up on my feed, and given my love of the awesome Amstrad PPC 512, I just had to have it. Advertised as working, though with a temperamental screen, I popped over the Humber Bridge to collect, and upon arrival the owner hastened to point out that it now didn't seem to be working at all. It made some noises like it was trying to do something, but nothing ever came up on the screen. Not to be deterred though, we agreed on a reduced price, and I still left with the machine under my arm. So the question becomes, what's going on with this machine? And more importantly, can I fix it? No, I can't. We'll get into why that is as we go through this video, and to be honest, I was in two minds as to whether to publish this at all, given that it doesn't have a proper outcome. But I decided there was enough to be learned from this video, by me and by you, that it was still worth publishing. So I hope you enjoy. It still doesn't work. So the ALT-286 and ALT-386 were Amstrad successors to their earlier PPC, or Portable Personal Computer, line of products. Those machines were designed to offer comparable specs to the original IBM PC, but by the time 1990 rolled around and costs began to reduce, Amstrad were able to offer a much more compelling design without increasing the cost too much. For a start, the chassis on this thing is metal rather than plastic, a big improvement from the creaky PPC line. It's pretty obvious that's the case given the damage to the paintwork we can see on this example, but actually I don't mind it that much. It shows this machine was well used at least. Inside this model, we can expect to find an Intel 286 processor clocked at 16 MHz, a whopping 4 MB of RAM, a 640 by 480 backlit LCD display, a 40 MB hard disk, and a user-accessible 16-bit ISA slot. On the outside, we can see that we have a 720 KB floppy disk drive on the side, along with a Centronics connector for adding a second floppy drive via an external caddy. I'm guessing that this is just standard floppy data and power cables mapped over to a Centronics connector, but we can check that once we get the machine open. Round to the back, we have an IEC power connector and power switch, and we can see that having the machine turned off while plugged in enables fast charging. And beneath those, we've got parallel and serial ports for connecting a printer, a mouse, modem, or other accessories. Next to that, we've got a bank of dip switches which are used for setting some of the BIOS features such as the RAM amount, the processor speed, and various other bits and pieces. And then over on the far right, we've got that user-accessible ISA slot, along with a 15-pin D-type connector for connecting an external VGA-capable display. We also have a smaller second bank of dip switches, and it looks like these are used to select between the internal VGA card or an external one connected via the ISA bus. On the other side of the case, we have a single AT keyboard connector for connecting an external keyboard, which I guess is useful. And then back to the front, we have a retractable carry handle, though, yeah, it's fair to say this is still more of a luggable computer than a true laptop. Before we continue, I want to let you know that this video is sponsored by PCBWay. I use PCBWay for all my PCB needs, and the service I've received has always been quick, cheap, and of a high quality. Simply upload your Gerber files and select the options that suit you, and PCBWay will give you an instant quote. They also have a fantastic project library, many of which include a bill of materials so that, if you want to, PCBWay can source the parts to construct the PCB for you. What's more, the project owners are paid a commission each time you order their design, so it's a great way to support independent creators. Order yours today at PCBWay.com. Opening the lid up, I'm immediately struck that the hinge is offset to the side, which, I don't know, aesthetically I kinda like. I thought it reminded me of the Grid 1550, but actually having looked that machine up, I must be misremembering it. If you have any idea what laptop I'm thinking of which had an off-center hinge mechanism like this, let me know in the comments. On the screen bezel, we have a little toggle switch, which I suspect is an inverter for the backlit LCD display, as well as brightness and contrast controls, which are important given that this machine has a grayscale display, which often means some tweaking is necessary to get a legible output. Beneath those, on the base section of the unit, we have some indicator lights for power, charging and drive access, and here's how I know that the system is, at least to some degree, working. If I flick the power switch on at the back, you can see we currently don't get a display output. But if we watch these indicator lights and listen for activity, we can see that the floppy disk drive seeks, and then there's a couple of seconds of hard disk access before everything goes quiet. I suspect what's happening is the machine is booting into MS-DOS and waiting at a DOS prompt, and you can see if I type in a basic dir command to get a file listing, there's some momentary access of that hard disk while it accesses the drive. What's more, if I press Ctrl Alt and Delete, the machine appears to reboot as we would expect. I connected up an external display to see if we could get an output that way, but there's still nothing showing up. I found a user guide for this machine online which gave some keyboard shortcuts for the graphics, but none of these seemed to affect what was going on the screen. So it looks like whatever issues this machine has, it's still booting and we're just not getting a display output. Time to bust out the screwdrivers. Flipping the machine over, it's easy to remove the original NiCad battery. Yeah, we won't be needing that anymore anyway. Then, if I remove a whole bunch of screws from the base and rear of the unit, I'm able to flip it back over and remove the whole top cover to reveal the machine's innards. There's always a hope when you're trying to fault find a machine like this that the problem just jumps right out of you when you open it up, but sadly, in this example that's not the case. We can at least go over the anatomy of the machine though. To the top right, we have the power supply section, and everything initially looks hunky-dory in there. And then over on the left-hand side, we can see the graphics card and the spare ISA slot. And again, everything looks pretty healthy. Below that, we've got the 720KB floppy drive on the right-hand side, and our 40MB IDE hard disk on the left. And below them, we have what looks to be a daughter board which contains the memory and BIOS for the system. If we look at the top half of the machine, we have the keyboard controller board, and the rest of the cables go over to a little breakout board near the display, or into the display housing itself. Before I delve too deeply, I wanted to check whether my assumption about this machine working was accurate. So I grabbed an ISA VGA card and plugged it into the expansion slot. I set the jumpers on the back to disable the internal graphics, and with a flick of the power switch, yeah, the machine booted straight up using the external graphics card. And we can see the machine does post absolutely fine, showing the 4MB of expanded RAM, and then boots into MS-DOS with no problems whatsoever. This message on the screen about bus settings worries me slightly, so I'll take a look at the jumpers on the back to check everything is set correctly. The first three jumpers define the RAM complement inside the machine, and they appear to be set just fine. Switch 4 is for 386 variants only and describes the page mode, and Amstrad say it should always be on. Switch 5 is for wait states and should always be off. Switch 6 changes the CPU speed between 8 and 16 MHz, and in this position it's set to 16, which is correct. Switch 7 defines whether the display adapter is set to mono or color mode, and in this position it's in color. Switch 8 enables the serial ports. Switch 9 is for 386 variants only and is to do with the pipeline. And switch 10 is for advising the system you have an external floppy drive connected, and in our case it's set to off. So it looks like this isn't the root of our problems, and it's time to focus on that graphics card in the first instance. Disconnected and reconnected each of the cables going into the card for the internal display, and you'll have to take my word for it here as I didn't get it on camera, but this did seem to do something. I powered on the machine and the display did seem to run for a few seconds before turning itself off again, so it does seem that we have a glimmer of hope of fixing this. To do anything further though, I'm going to have to delve deeper, so at this point I'm going to fully dismantle this thing and see if I can work out what's going on. Thankfully the machine is pretty easy to disassemble. First the memory expansion board comes out, and then we can get to the floppy drive which pops out with no issues. Then onto the power supply, and finally we can get the ISA riser card out. One thing I did notice was this Vata backup battery, which thankfully doesn't seem to have leaked. What's weird is that it's placed rather randomly between the hard disk and the battery bay, and it's just sort of floating there. If I chase the cable, it links over to the other side of the motherboard where it's soldered directly. Now, photos online do show that this is the appropriate place for the backup battery to be connected, but in all the photos I can find, it's a NiCad cell soldered almost directly on top. The fact that we have a nickel metal hydride battery on a fly lead suggests that maybe this was an aftermarket job? In any case, I'm just going to remove it as I don't plan on using this machine often, and I'm happy to reset the time and the hard disk settings if it means I don't have to worry about batteries leaking. Looking at the ISA riser, it looks almost as though something has leaked here. There's an oily substance on the surface of the plastic housing, and there's what looks like some dust or corrosion on the connectors themselves. It could be that some of these capacitors have failed, though it would be weird that a VGA card in the ISA slot would still work if that were the case. I also noticed this capacitor on the back of the riser. At first I thought this was a mod by someone, but having referred back to some images online, I can confirm it's stock. And it's the only component that interacts with the inbuilt VGA card that doesn't also interact with the ISA connector. In any case, it's a 35-year-old capacitor, so I'm going to replace that along with the other 4 on this board just to be sure. I ordered in a suitable replacement cap for the one on the back of the board, though when I tested it in my component tester, the original was still testing out okay. Still, it's 35 years old, so it's a good idea to swap it out. For the ones on the other side of the board, in theory these only interact with the upper ISA slot, and that's working fine. But I'll go ahead and remove those with some assistance from a manual solder pump and some braid, and give those a test as well. Initially I thought I might be onto something here. I'd originally thought that all 4 of these caps were 10 microfarad, and a couple of them were testing much higher capacitance than that. The lesson learnt here is not to assume that just because all capacitors look the same and are all in a neat row, that they're the same value. I didn't have any spares for these 33 microfarad caps, and seeing as they're all testing fine, I just reinstalled them for now. I can always order in some replacements and swap them out later if needed. While I was here, I also gave all the connectors a clean with some IPA and a cotton bud, and then blew them clean with some compressed air for good measure. With that, it was time to get the machine back in some semblance of order, enough to see if I've fixed anything at any rate. Unfortunately, yeah, there's still no output on the built-in display. Though reassuringly, if I connect that VGA card back in, we still get an output to an external monitor, so at least I've not broken anything else. Annoyingly, we're still not getting an output to an external monitor using the original graphics card either, but I suspect that's because switching to the external display seems to require a utility installed on the hard disk, and we just might not have that installed right now. We'll carry on with the fault finding shortly, but I'd be remiss not to point out that at this point I picked up a certain fishiness coming from the power supply, so we're going to whip that out and take a closer look. Getting the power supply under my microscope, I can clearly see that some of these caps have leaked, so I'll go ahead and replace all of them, which is going to necessitate ordering in because I don't have everything I need.
Several days later.
Right, so all my caps have now turned up, and it's time to look at removing the old ones. I'm not quite sure how I missed the extent to which these caps had leaked, but I suspect it's time for an eye test. To get them out, I'll be heating the pads for each of the caps in turn before removing them. This went quite well, other than the continued fishy smell attacking my olfactory sensibilities. The 400 volt cap was by far the hardest to get out. This footage isn't slowed down, this is actually how long it took for the existing solder to flow before I could suck it out. It's both mesmerising and frustrating if you happen to be the one trying to remove it. With all the caps removed, the extent of the leakage was laid bare. It's a miracle this thing worked at all. I gave each of the affected areas a clean with some isopropyl alcohol and some cotton buds, and the bits I could get to came up really well. Unfortunately, I couldn't get all of the board sparkly clean, That would require an ultrasonic cleaner, which I don't currently have. But if you watch all of my videos on a loop, I stand a fighting chance of affording one in the future, so thanks. The back of the board was easier to clean. A spritz with some IPA, a scrub with a toothbrush, and a going over with a microfiber cloth was enough to get it looking back to factory fresh. And now it's time to get all the new caps installed. Or it would be if my fur baby would let me be for a second. After she'd had some fuss, it was time to get the new caps in, and with all that done, the PSU should be good to go. So, was that the problem? Or was it just a problem that we needed to take care of? Okay, that's really disappointing. The good news is the machine still boots, but unfortunately we don't have any output on the display. I switched the pin switches on the back to use the external VGA card and confirmed that's still working, so it looks like our problem remains. So now we need to focus where I probably should have started originally, the display itself. It does seem to have power, as when you power the unit off we do get a brief flash of backlight, but after that it seems to be completely dead. Time to open her up. First off, we just need to remove a screw here on the front bezel, and that gets us to the display circuitry. If we remove these screws on the screen unit itself, we can then remove the bezel and get a much closer look at what's going on. The blue and orange cables here are likely our display signal through to the panel, which then transitions to this white ribbon cable here to interface with the display. And then these white cables will be for the display backlights. Everything is pretty well packed in, so before I go removing everything, I just wanted to check if power was at least getting to this board with the machine on. And yeah, it looks like there's no power getting to the LCD backlights. Flipping the machine back over, I then chased the cables from the display board back to the graphics card, and it looks like everything, including the power, is routed this way. Looking at the graphics card itself, the two larger connectors on the right here are the ones that connect to the display panel's circuit board. This next one connects to the LED cluster PCB, which tells us whether the machine is on and whether any drives are being accessed. And then this last one doesn't go to the top half of the case at all, instead it goes over to the base of the motherboard here. I thought this might be power from the motherboard over to the display unit, but it was at this point I did something really novel and tracked down the service manual, and it turns out this connector is just the signalling for the drive status LEDs. Okay, so armed with that manual, we can see that connector CN502 handles the power delivery to the LCD, as well as the brightness and contrast. That's this one here, and if we stick a multimeter over pins 6 and 8, we should get minus 24 volts, which we don't. But interestingly, if I go across pins 5 and 8, I get minus 12 volts, which makes sense because pin 5 is the 12 volt rail. Read the f***ing manual, Matt. Pin 6 connects straight to 0 volts, and you haven't screwed the card down. It has no ground plane. Gordon Bennett. Okay, so with the ground plane intact, we can see that we still get minus 12 volts across pins 5 and 8. But if we go across pins 6 and 8 to get that 24 volts, something really weird happens. Watch the multimeter carefully here. Did you see that? We briefly get a negative voltage, but as we hold the probes on, it steadily drops until we get nothing. So at this point, I trace the minus 24 volt signal back through the graphics card. It goes via this voltage regulator on the card, and then passes through a couple of transistors on the back, and then goes to a pin on the ISA riser, which is weird because normal ISA doesn't provide minus 24 volts. But again, reading the manual, I can see that there are several additional pins on the graphics card's connector, and these receive additional power and signaling from the motherboard. Tracing the motherboard's connector back shows that we get the minus 24 volts direct from the power supply via this connector. Now on this one, pins 1 and 2 are both 5 volt rails and there's no issues there. Pin 3 is positive 12 volts and that's just fine too. Then we have minus 12 volts on pin 4 and that's just fine. And then we should get our minus 24 volts on pin 5. Oh, well, that's definitely not right. that minus 24 volt rail is all over the place. I triple checked this to make sure I was getting a good connection, but it definitely looks like we've got some problem with the power supply still. And annoyingly, I've not been able to find any schematics for it online, so I'm a little bit stuck at this point. It's weird that all of the other output voltages are just fine, but actually if you think about it, this makes sense why the PC itself will still boot even though the monitor won't work. It's only the monitor which uses the minus 24 volt rail, so it's no surprise that the machine boots just fine in all other regards. But given that we're getting much more voltage out of this rail than we should be, it's likely that the transistors or voltage regulators on the graphics card are fried, or worse yet, the display panel itself may have been damaged by the higher voltage as well. So what now? It's not like replacement power supplies for these machines grow on trees, and neither do the graphics adapters or display panels. So for now, I'll just have to leave this video here until such time as I can source working replacements. It's a shame because my initial plan for this video was to add a sound card to the external slot, and then I would have had a lovely example of a 286 DOS machine to play around with. As it stands, this one will be boxed up and secured in the garage until such time as an opportunity presents itself. Sometimes that's just how these projects go, and the reason I'm still sharing it with you is because I learned a hell of a lot about how to fault find through this process, and I hope you do too. I mean, if I'd taken the time to check the schematics before I started blindly poking around, I would have cut out a whole middle part of this video that you wouldn't have had to see. I probably wouldn't have changed the end result, but we would have got there quicker. If you made it this far in this video and you've got any ideas on things I can try to get this machine working, please drop them in a comment below and I'll be sure to get back to you. Other than that, thank you so much for watching. If you have liked the video, there is a button explicitly for that, and if you want to see more of this kind of content from me, I'd love it if you would also subscribe to the channel. Other than that, thank you so much for watching, and I'll see you again soon. Bye bye.